Hi students, now we'll talk about section 3.3, which is about projectile motion. If you look at the scheme in the book, page number 75, the projectile motion, this is the shape of the projectile motion. If we have a body object and this body have initial speed and this speed with angle, initial angle. The initial speed is v naught as a vector and the initial angle is alpha naught. In this case, this initial velocity has two components, the parallel or x component, which is v naught x, and the y or vertical component. When the body moves along this trajectory, this is the shape of that trajectory. At each point, the velocity for that body will change depending on the time and its place. We have two velocities now. We have a vertical velocity and horizontal velocity. In this experiment, in this problem, we neglect the air resistance. There is no any resistance. In this case, first of all, the horizontal velocity component will stay the same. You can see here Vx naught is equal to, this is the first point, second point, third point, and finally we can take as we like points along this trajectory. At point number 1 we have v1x. At point number 2 we have v2, velocity 2, and this velocity number 2 has an x component, which is v2x. Here also we have the third point. This is the velocity. We have x component and y component. This is vx. Along all the path, the x component is constant. But what if we look at the y component of the velocity? Initially, it is in this direction and this magnitude, but when the velocity comes to the any other point, the vertical component of the velocity will change. For example, at the highest point, point number 2, the vertical velocity is 0. It is a returning point. If we look from this side to the motion, we will see just a body going up and then going down. At the upper point, the vertical velocity is 0, as we know from before. Also, the motion now under the gravity and the acceleration of gravity, which is g, which is minus in direction downward 9.8 meters per square second. If we look to that third point, for example, we have the same horizontal velocity and we have downward vertical velocity, which is v3. We can compute it. And the velocity vector in this direction, it is its slope with angle alpha. The angle alpha, firstly, it was alpha naught, but later it will change. In this case, for example, at point number 2, the highest point, alpha is 0. Here, alpha is alpha of t, depend also on t. We can find it, we will see that. Okay. The equations of motions, we have two groups, two sets for equations of motion. If you remember the equations, v2 is equal to v1 plus at, v2 squared is equal to v1 or v initial square plus 2ax, and x is equal to x naught plus v naught vt plus half a t squared. We have two sets of equations. The first set for horizontal motion and the second for vertical motion. These two sets will reduce because we don't have acceleration in x direction. So any term with acceleration in x direction will go to zero. For example, if we have v2 is equal to v1 plus at, a in x direction is equal to zero. This term will go. And we have, this is vx and this is vx. So vx finally is equal to vx initially. Also this equation, v2 squared in x direction is equal to v1 in x direction squared plus 2ax. The acceleration is zero. Then we have v2 squared is equal to v1 squared, which is the same first equation. So the first two equations are the same. Also x is equal to x naught plus v naught in x multiplied by t plus half a t squared. In x direction the acceleration is zero. So we have just these two terms. This is, if we suppose that x naught is equal to 0 at origin, then we have x is equal to vx multiplied by t. So we have just two equations in horizontal motion, which is x is equal to vx multiplied by t. It is the simple equation of velocity. And vx always equal to vx at t equal to 0. And we start the motion from 0, 0. What about the y? The vertical motion. We have three equations as we said from before. v2 in y direction is equal to v1 in y direction plus a it is that plus a multiplied by t. v2 squared is equal to v1 squared in y direction plus 2a multiplied by y. Also we have y is equal to y naught plus v naught in y direction multiplied by t plus half a t squared. Now be careful that we have the acceleration is g and its direction in negative, and g is equal to 9.8 meter per squared second. So the minus sign is for the downward direction. V naught y v1, which is the initial velocity here, or at any initial point. Also here we have g with negative sign. Also we have g also here. So we have, if we have y naught is equal to 0, then we have two terms. So we can find that y is equal to v naught multiplied by t minus half g t squared, and vy is equal to v naught minus g multiplied by t, and y here is equal to 0 if it is y naught. So the first two equations will be the same also. We'll combine it with the third equation. Now we have two sets of equations in x direction and in y direction. Now what is vx naught? We have v naught as a vector. The x component of that vector is v naught cosine alpha naught. Okay? So if we take vx we can use it in x and Vx formulas here. We need to put V naught cosine theta in place of x, Vx, because it is constant, which is equal always to Vx. What about Vy? Vy is equal to V naught sine alpha naught. We can use it in the place of V naught in the formulas. So the Y formula will be V naught multiplied by T by sine alpha naught minus half GT. Also Vy is equal to V naught minus GT. V naught is equal to in Y directions V naught sine alpha. As we know, we have for any motion, we have a position vector and velocity vector. Also we can find an acceleration vector. We just need to derive, but the acceleration in x direction is 0 and the acceleration in y direction is negative g in downward. So if we need to write the acceleration vector, it will be equal to 0 in I direction minus g j direction. This is the acceleration vector. It is simple. Now the position vector, we need to take the position components in x direction, which is v naught t cosine alpha, in y direction v naught t sine alpha minus half gt squared in y direction, and the velocity vector is v naught cosine alpha plus v naught sine alpha minus g multiplied by t. If you look to them, they are the first derivative of the position vector. What is the distance from the first point and the initial point, or any, which is r? We can use the Pythagorean theorem to find the distance, which is rx squared plus ry squared under the square root, and we can find the speed of that body, which is vx squared plus vy squared under the root, to find the speed. And we can find also the direction of that speed by using the tan inverse relation, which is tan inverse to vy over vx. Okay? Now if we need to find, you know that from mathematics, this is x squared, for example, and this is relates to x cubed, which is a function y is equal to x cubed, and this is function y is equal to x squared. This is a trajectory function, okay? If we need to know the shape of our trajectory, that means we need to write y as a function of x to know the shape of our trajectory. We have the equations y and x, and we have a third parameter, which is t. We need to remove t from both of these equations and use it to connect them. From the first equation, we can find that t is equal to x over v naught cosine alpha. Then we need to put this value of t in y equation. Then we will find that y will be equal to sine over cosine, which is tan alpha naught multiplied by x, minus g over 2 v naught squared cosine squared alpha x squared. It is just like the equation y is equal to a plus bx minus c x squared. It is a parabola formula with negative sign. With that means the parabola direction is not upward because the minus sign, it is downward. And A, which is the constant, is equal to 0. It is the starting point. Depending on C and B, B is equal to tan alpha naught. C depend on G and V naught and cosine alpha. Depending on the values of B and C, we have different altitude and range for the trajectory, but all of them are parabolas. Is that clear? Now let us solve this example for an object projected horizontally from an edge of a table. If we just hit it, and this object will have horizontal velocity v naught, the angle, the initial angle is 0 from the x axis. If the magnitude of that velocity initially was 2 meters per second, and the body will move with, it will have its velocity and an angle from the x component alpha of t, it will change, but initially it is 0. Alpha 0 is equal to 0. In this case, we have two components, Vx and Vy. We need to find the position vector and the velocity vector as a function of time. Then we can apply any time. We can put 2 seconds, 3 seconds, as we like. And we need to find that with respect to the edge. Okay? Now, we need just to use these equations. And we need to find the position vector and the velocity vector. Now, for horizontal motion, Vx naught is equal to V naught cosine alpha naught, but alpha naught is equal to 0 and cosine is 0 is 1. V naught is equal to t as given. So Vx is always equal to 2. What about the position? The position is equal to V naught t cosine alpha, as we find from the first sheet. Okay, V naught is equal to 2. The time is equal to time. Cosine alpha naught is 1, 0, and cosine is 1. Then we have the relation x is equal to 2t. This is the x component for the velocity and the position. What about the y or vertical motion? We have Vy naught is equal to V naught sine alpha naught. Alpha is 0, sine will be equal to 0. Then the velocity initially it will be equal to 0. It is just like a free fall object. But if we look to this falling object from the side, we will see it as a free fall. Okay? We can use the velocity relation, which is V naught sine alpha, which is equal to 0, sine alpha naught, minus g multiplied by t. G, it is 9.8. So the velocity will equal to minus g multiplied by t. What about the position? The position is equal to V naught multiplied by t. Sine, which is equal to 0, sine alpha naught, minus half gt squared. Then y will be equal to minus half gt squared. Now we can write the position vector and the velocity vector. We just need to r is equal to rx in I direction minus half gt squared, which is ry in j direction. This is this is rx, the x component of the position, and this is the y component of the position. And the velocity, this is the x component of the velocity, which is constant, and this is the y component of the velocity. So we have the R component, the position vector and the velocity vector. These two vectors for our example are the same. These two position and velocity vectors are obey these two relations, the position and velocity vectors. Always we can use them and find these vectors directly. What about the direction of the velocity? Tan alpha at any time is equal to Vy over Vx, I'm sorry, which is minus Gt over 2. So alpha at any time will be equal to tan inverse or arc tan 2 minus Gt over 2. You can put any time you need in these relations and find the position, the velocity, and the direction of that velocity at any time. Use t equal 1, 2, 3, 0 as you like. That's all for the first part of projectile motion. Thank you.